irresistible force such as you meets an old immovable object like me.
First, I'd like to introduce you to some vocabulary we're going to have during this section. The terms I need you to be able to use are boundedness, lower bound, upper bound, and bounded. For instance, the function 3x squared minus 4, we're going to say has a lower bound, or it's bounded below. You're going to find it's pretty easy to determine the concept of boundedness from the graphs of these functions. Another function I'd like you to take a look at would be 5 minus x to the 4th. This one we're going to say has an upper bound, or it's bounded above. This function, 1 minus x cubed, we're going to say is not bounded above or below. On the other hand, the function f of x equals 3 is bounded, and we're going to simply say it's bounded. When we say it's bounded, that means it's bounded both above and below. Another example of this situation would be x over 1 plus x squared. It's an interesting looking graph, but it's bounded above and it's bounded below. So we're simply going to say this function is bounded. And now a little more vocabulary we have to introduce. Some terms I need you to get comfortable with. Local extrema, local maximum, and local minimum. You see, many of the graphs we will study will have peaks and valleys with a change from increasing to decreasing and vice versa. The extreme values of a function, or the local extrema, can be characterized as either local maximum or local minimum. Let's take a look at this function. X cubed minus 4x plus 1. I'm going to use the trace function, and I'm going to dance my little spider up and around here. Now the end spires have a nice trait. When I hit the maximum, a local maximum, it'll give me the coordinates of that point and indicate it's a maximum. Same if I hit a local minimum. Now you realize that these aren't minimums or maximums for the function. They're just local. It's just a local maximum in some tiny interval. This function, I'd like to use a different aspect of the inspire. I'm going to analyze this. I'm going to click once, and I'm going to select a certain part of the graph, and it's going to find the minimum for me. Let me do that again. I'm going to try a local maximum. A maximum just in this area. So click, and then move it over, and click, and there's my local maximum. Make this a little easier to read. Later on in calculus, we will have methods for analyzing functions, but for now, I only need you to be able to approximate local extrema using a graphing calculator. And that's about it for this lesson. Let's just recap. So now you know about boundedness. You can tell a lower bound, an upper bound, and a bounded function. And you know about local extrema. You can identify local maximums and local minimums. And you have two different ways to find the mins and the max. You can trace, or you can analyze the function. And that's the end of a very quick lesson. Thank you for your time and attention.
As we live, something really got to